Good morning, everyone. Now the recording started. Okay, today we're going to talk about two important topics. One is called multi-threading. Multi-threading. The other one is called exception handling. So both of these topics are very important, both in terms of interview calls as well as once you join any organization you'll be using. This one I'll explain whatever is needed for your day-to-day life and interviews. Okay, and this one I'll explain in detail because you deal with it almost every single day, every single minute, with these exceptions. But the multi-threading, we don't use every single feature that Java supports. That's why I give whatever is required, and both in terms of interviews and once you join the organization also, whatever you need to deal with it, whatever is required, I'll teach that one. So let's get started with multi-threading to start with. So when we talked about Java's fundamental strengths, what are the core strengths of Java? Java is secure, Java is portable across all the operating systems, write once, run anywhere, and programming languages before Java used to sweep its memory. They used to garbage collect their memory. Once the memory gets allocated, once you are done using those objects, and then once the references are all removed, then it's your responsibility to collect it. That's called garbage collection. But that was not automatic. You have to dereference all these objects. It's your job as a developer to take care of cleaning that mess. But Java introduced this garbage collection, which automatically takes care of it. Similarly, one of the strengths of Java is it supports multiple threads, multi-threading. What exactly is a thread? What exactly is a process? I'll show you with this as an. I'll talk about this concept with an example. It's a standard example that everyone takes it. Okay. So we have Microsoft Word, right? We have Microsoft Word, Excel, PowerPoint, and all this. So when you start Microsoft Word, it starts a new process. It starts a new process. So it will create a new instance of the Microsoft Word, and then you can start writing. So what is this process? Process is when you open the Microsoft Word, whatever the memory that's required for Microsoft Word, for your Word document that you're talking about, this is the one I'm talking about. So this is the Microsoft Word I'm talking about, right? So I open up a new process. So here I keep typing here. Something like that. Okay. So there are a couple of things that happen in Microsoft Word. As you keep typing it, that whole Microsoft Word is if you think of it as a process, it is actually a process. As you keep typing, okay, if you turn on the error checker, or spelling mistakes, okay, typos. If you turn on that feature, what happens is as you type, it identifies the typos and give you in red mark saying that, hey, I'm sorry, what are you talking about? I don't recognize a word. You have misspelled it. As you type it, Microsoft Word is writing into the Word document, but behind the scenes, it is also checking for errors. It's checking for typos. So within a single process, there are actually two paths of execution. There are two things that are happening behind the scenes. One, as you type, one way is as you type, I'm typing here, okay? As you type, one approach is you just type everything and then say, hey, can you do the spell check? Sure, I'll do it. That's one way. That's serial fashion like this. I'll do my first step. I'll type first and then do the spell check. This is serial fashion, meaning I'll do one after the other. Is it efficient? Is it efficient? It's too late, right? Can you do the spell checking while I'm typing? While I'm typing, one path of execution is displaying whatever I am typing and putting into Microsoft Word. The another path of execution in parallel, keep this in mind, we are not in serial mode now. We are doing it in parallel. One step is taking all of the characters that I'm pressing and putting into Microsoft Word. The other path of execution, meaning another lightweight process. You can call this one also a process, but this is a very lightweight process. This lightweight process they named thread. So process is here. The whole Microsoft Word is a process. Within that, if you want things to happen in parallel, not in sequential, then you can span multiple threads. All these threads are running, are executing in parallel. This guy is doing here, this guy is doing its job. This is a grammatical error check thread. This is spell checker thread. This is some other thread. This is some other thread. So what exactly is happening is as you type, this is your typing stuff, typing thread. So each one of them, each thread is doing its job in parallel. There is no sequential step. Ideally, or one way to do it is 0, 1, 2, 3. First step, you finish your first step and then go to second step, third step, fourth step. This is how you do it, right? But this is not efficient. I want my grammatical error check and typo check, both of them to happen in parallel while I type. Within the same process, there are multiple paths of execution. All these small processes, they're called threads. All these threads are running in background, in parallel, and they do their job. This is called multi-threading. So this is called multi-threading. Each one is a thread. This is first thread, second thread, third thread, fourth thread. All these threads are running in parallel within the same process of Microsoft Word. So now let's get back to, let's not worry about Microsoft Word. Now let's get to Java. So Java supports multiple threads as well. What exactly do you mean by that? Well, what I mean by that is I have 4 things to do. Okay? In my public static void main, that's where JVM kick starts, right? So in public static void main, I have 4 things to do. Okay? Each one takes its time. This one take couple of seconds. This takes couple of seconds, couple of seconds, couple of seconds. So you have to finish this first, you have to finish this first, you have to finish this, and then come to next. This is called serial processing. One thread at a time, just one execution at a time. If you have a scenario where you want all of these things to happen in parallel, you can do it, and Java supports right off the bat. Java supports that. You don't need to do these things in serial fashion, especially if they are time consuming, resource intensive process, then it's not a good idea to do it in serial. You don't have to. This guy doesn't have to wait until this one is finished. These 2 things can happen in parallel. So you go here, boom, 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 boom. You can span. This is called spanning a thread. You can span new threads within the same process to get the feeling. Not only the feeling, it's actually things are happening in parallel. No one is waiting anymore. Third guy is not waiting for first and second to get finished. Not anymore. You can span new thread and assign, hey, this one, for example, everyone, simplistic scenario, I'm taking it. Okay. Later on, I'll tell you some real business use cases where you want to use it. In this example, everyone is printing 1 to 10,000. Printing onto the console. Okay. This guy is printing 10,000. This guy, this guy, this guy. So this guy, but the requirement is, I don't want this guy to wait. All these things can go in parallel. Then don't wait. So span a new thread, create a new thread, and assign this task to this thread. And then span another thread, assign this task of printing 10,000 to this guy. Span one more thread and assign the task of printing 10,000 to this guy. Do the same thing. And now they are running in parallel. So multiple threads within the same process. Why can't these be multiple process itself? Well, as I said, process is a heavy weight. But thread is lightweight. Process is heavyweight. The whole Microsoft Word. Do you want to span one more Microsoft Word just for the spell checker? No. Within the same process, we are talking about the same program here. So within the same program, I have this 100 lines of code, which is doing 4 different things, 1, 2, 3, 4. But 2 doesn't have to wait until 1 gets finished. Let's run them in parallel. But within the same process, keep that in mind. Within the same process, these threads will run. These threads are also, that's why these threads are also called sub-processes. Sub-processes are threads. They are lightweight. Once that gets started, some memory will be allocated, and then the task will be given to that and say, boom, go ahead. And especially in the multi-core technology, now we are not working on a single core anymore, right? Everyone is having multiple cores. Even our laptop has 2 cores or 4 cores. Desktops, we have like 6 to 8 cores. Even home desktops, forget about the servers. Servers, you can have so many number of cores. Processes I'm talking about. So you can leverage this multi-core technology. Within the same process, you have this multiple cores now. So you can code in such a way that all these things can happen in parallel. If you use this, if you want to use the underlying hardware architecture of multi-core, then you don't have to do the things in serial fashion anymore. You have the hardware to support that. So use that hardware, leverage that, and then you do things faster. And your application will be more scalable, meaning more people can use it with the same resources. If you have the multi-core, especially with the multi-core process, you should take advantage of this one. Anyways, keep away let's not talk about this hardware architecture, hardware and multi-core and all that stuff. But within the same process, you can span multiple threads, and Java supports this multi-threading. And in fact, this is one of the fundamental reasons why Java has been chosen. It has been chosen as server-side technology instead of CGI at that point. So later on, I'll talk about the web technology frameworks, and some history behind that. So people used to use something called CGI, which used to span a new process for every single user, for every single web request. But within the same process, you can span multiple threads. So Java came up with this idea of multi-threading. It says, hey, I support multiple threads. Then that's one of the main reasons why Java has been chosen for the web technologies, server-side technologies, especially. Later on, we'll talk about it. There is a concept that we talk about later on called servlets. So there, with every web request, we only span a new thread. We don't start a new process, brand new process. We don't start it. All we have to do is just create a new lightweight thread and assign the task, and then have it taken care of it. Okay? So your application will be more scalable. What exactly do I mean by that? If your application supports 100 users, if 100 users can come and shop in your website yesterday, now the same application using multi-threading, it can support 1,000 people or 500 people. That is what I mean by scalability. So your application will be more scalable. So that's about multi-threading. So now let's get down to the actual ground and see, how do we create a new thread? How can I span a new thread? In Java, it can be done in two different ways. Java has given two different options. If you want to span a new thread, this is how you do it. Have your class, whatever the class that wants to span new threads, that class, there are two options. One is you can extend a class called thread. This is in java.lang package thread. So have your class, my class extends thread. And this thread class has a method called run. You override this method. Public void run. You provide the implementation here. What do you want to do when this new thread spans and started? The life cycle of the thread is, once the thread is created, as soon as the thread is created, it is not runnable. Meaning you cannot run that thread immediately, but behind the scenes, it will assign some memory and all the needed resources, and then say, now your thread is runnable. Yes, go ahead and run. When your thread wants to run, what do you want to do here? This is where all of your expensive operation goes. Earlier we talked about printing 10,000 numbers, right? So that goes here. The actual business logic or your spell checking goes here in the case of Microsoft Word. Okay, so that's your, this is where you write the actual logic. Okay, then how do you start the thread? How do you span it? This is where all the logic goes. Once this thread gets started, spanned, and then once it is runnable. But how do I start the thread? Well, this is how you start the thread. It's simple. All you do is new, you create an instance of the thread. There is a class called thread, right? Java.lang. So you create a new instance of the thread and then say, just start. Here, this constructor takes the object which extends the thread class. So where do we want to span the thread? Where is the code? When thread starts, this is going to call the run method. JVM is going to take care of that. So here what you have to do is when you create the new thread, you have to say, hey, who do you want me to run? Which class? Where is that? Where is that logic? Well, in this case, in your class, since you are in the same class, you can say this here, meaning this objects. So start the new thread for this object here. Then it spans a new thread here. It just spans a new thread here. And then as soon as you call the start method, JVM will look for it. Hey, which object is he talking about? Oh, he's talking about this object, meaning wherever he is in this class, my class. Okay. Yeah, my class extends thread. That's cool. So, okay, you want me to start the thread? Sure. Do you have a run method? Did you override the run method? Otherwise, it blindly calls the run method. Okay. But whatever the run behavior that you get from your parent is nothing. It's just blank implementation, right? But you want to override that. And you did. So it just calls the run method and your new thread started. This guy started. Now do the same thing again for this one. So every time this line of code gets executed, every single time this line of code gets executed, a new thread spans. Resources get allocated, and then your run method will be called. Simple. Every time this line of code gets executed, a new thread will be spawned. Resources will be allocated, whatever the resources, and then run method will be called on that. This is one way of doing it. Something wrong here. Extends thread. Extends. We know extends is never a good idea, right? Because you're freezing the design. Well, Java has provided one more way of spanning a new thread and preferred way of doing it. Same thing. My class implements. So obviously implements. So there is an interface called runnable. This runnable has a method called run. Same method. Whatever you have here, public void run, you have the same public void run, and you write the actual logic that needs to get executed when new thread spans. Okay, and again, this line of code doesn't change too. New thread of this, that start. Whatever the object, wherever the new wherever you want to span a new thread, give that object, what does it do? It simply calls run method on this object. It's that simple. Since you happen to create a new thread within the same class, so you are just doing this. So your run method gets invoked. So there are two ways of creating, spanning a new thread. One extends thread class, two implements runnable class, and you provide your behavior in public void run method in both the scenarios. You override run method in the case of thread, or you implement run method in the case of runnable. You do one of these two. And then all you have to do is new thread dot start. Simple. And then it calls the run method on the object that you passed. It creates a brand new thread. So you call that 10 times and then 10 threads will be running in parallel, not serial anymore. You're not running in serial anymore. Everyone can do their own job in parallel. Nobody is waiting for anyone here. That's the beauty of multi-threading. Okay, I'll leave it at that and show you an example, a simple example of how this can be done. I'll create a new package. We'll get to questions a little later. Okay. Now, this is what I'm doing. I'll create an expensive operator. I'll create a method that prints 1 to 10,000. Okay, it takes time. So what I want to do here is are time consuming, expensive. I call it an expensive process, meaning it takes time. It takes time and the resources. That's what I mean by expensive. Okay. So here I have a method called public void print. In fact, you can call this as printer too, whatever you want to do it. Okay. Public void print. My goal here is I want to print 1 to 10,000 on the console. Okay, I want to print 1 to 10,000 on the console. So I'll say for int I equals 0. I'll say 10,000. Printing to the console takes few milliseconds, right? So that's why I've taken this little expensive operation. Simple. Okay. Let's go and create I'll say thread demo. Yes, I want main method. Now let's do it. I'll say expensive process equal to new expensive process. Okay. I didn't like the name actually. but because we are just printing it, ideally, if you know the business, ideally there should be a printer or something like that. Console printer, maybe. Yeah, let's not call this expensive process. Let's call this as console printer. Refactor it. Never settle with whatever you have written. Always try to improve it. Always try to improve it. So console printer dot print makes a lot of sense. Now I like it. So console printer dot, now this is printer. You know what I'm doing here? Alt Shift R. Then I do, see, I'm just selecting it and then refactor, rename. See here, Alt Shift R. When you do that, then you change, as you type, it changes all the instances. Refactoring. Anyways, well, it printed all 10,000. Very sweet. Very good. Very good. Very good. Okay. So what I want to do here is, I want 4 threads to run in parallel, and I want this 1 to 10,000 to be printing 4 times. Okay. Not a big deal, right? Just call this guy 4 times and see what happens. Right? So what exactly happened? Okay, 0 to 10,000. Okay, after again 0 to 10,000, and then again 0 to 10,000, and then again 0 to 10,000. So it printed 4 times. Right? Now what I want to do here is, when I print it, I want to print the thread name. Okay, there is a way you can print the thread name. So I'll say this is how you can print the thread name. Thread has a static method called current thread. Thread class has a static method called get current thread, and now get name. So I'm printing the thread name also, just for curiosity. Okay, like that. See here, it's saying main thread, main thread, main thread, main thread, main thread. This is called main thread. When JVM kicks off and invokes your main class, so JVM behind the scenes, you don't have to create a new thread. JVM behind the scenes creates a new thread, and all of your work will be done within that thread itself. So you don't have to do it. Behind the scenes, JVM creates a new thread that is called main thread. When you kick off your public static void main, that's what happens. But what exactly is happening here? Things are happening in serial fashion. I don't like it. See here, this guy is printing 1 to 10,000, this guy is printing 1 to 10,000, this guy is printing 1 to 10,000, and after this guy comes next. So we are waiting. This guy is waiting until this guy finishes. This guy is waiting until this guy finishes. No, I don't want this. I want this to be done in parallel. Multiple threads. Let's do it, okay? So now what I want to do here is this public void print. Now let's take the first approach. Now every time someone calls my print method, okay, this guy is calling the print method 4 times. Every time someone calls me the print method, I want to span a new thread and assign this task to that thread, and then give back the control to my caller and say, I'm done printing. I mean, I just spanned a new thread and it's doing its job and you're done. So that he can go back and then he can call me again. When he call me again I'll create one more thread and then I assign the job and then give back here. And then again this will call print 3rd time, and then I'll again create one more thread and then assign that task so that he can call again this print, and then I'll do the same thing. So I'll have 4 different threads that are running in parallel, that are printing in parallel. No serial anymore. No one is waiting for the other guys anymore. Okay, let's do it. How do I do it? The first approach here is extends thread. What is the first step? The first step is you should extend thread or implements runnable, and then and the next step is you should override the run method. Override the run method that you have in thread. Thread class has a method called run. You have to override it and write your behavior. What do you want to do when a new thread spans? Well, what I want to do here is I want to print 10,000 times all the numbers. I don't like this one. You know what I'm saying? This is what I want to do. This is my business logic. When a new thread spans, what do you want to do? Is get return in public void run method. And now, but somebody has to span a new thread and somebody has to start the new thread, right? Who does that? Well, this print method. When someone calls print, I will not do myself anymore. I'm part of the main thread, right? I will not do it. I'll span one more thread and assign that task to this guy. So how do I do that? Well, new thread. Okay. Dot start. Okay. If you have a different object, if this public void run method is there in a different class altogether, okay, you want that class's run method to be called, then you provide the appropriate instance of it here inside this one. Okay. Or since you have this run method inside your class itself, what you are saying is, hey, I want a new thread to be spanned within this object itself. That's the default behavior anyway, even if you don't provide it, but I'm just throwing out there. You know what I'm saying? Did you all understand this there? If you just take out the public void run method and extends thread, if it's done by someone else, then you can say new thread of that guy dot start. So that guy's run method gets called. In fact, we don't call run method. We are not calling the run method directly. What happens? All this while we have seen this behavior, right? What's the big deal? Run is a method and I can call run from here. Absolutely, you can do it. But do you want to see the behavior? Do you want to see the behavior? It's a plain, simple serial fashion. Main thread, main thread, main thread, main thread, serial, serial, serial. No one is spanning a new thread there. You're just calling this method. That's all. You just refactor to move the logic into a different method. That's not what we wanted. This is what we wanted. I want to span a new thread. I want to span a new thread and then start assigning something. Okay, this run method gets called. Okay. Now, do you want to see what exactly happens with this one? Now let's see how things happen in serial, parallel. I'm sorry. Beautiful. See here. Thread 1 started, I equals 0, and then immediately thread 2 started. So what happened here? This guy called the print method. It came here. It spanned a new thread and say, hey, you start. And then it's happening. While it's happening, this guy told the thread demo that, okay, I'm giving back to you. I span a new thread and I'm done with my printing. Now you tell me. Now this guy called this print again. Went here again. It spanned a new thread. Okay. That guy is thread 2. And now thread 1 is happening already. This guy is doing its job. And now thread 2 started. It's doing its job. But as soon as the thread gets spanned and started, again it goes back to the caller, right? And now this guy is saying, hey, can you print again? Absolutely. Now this guy came again. The main thread, the main guy is calling the printer.print. Then this guy says, okay, sure, but I don't print myself. I have an assistant. I'll create a new thread and then I'll have him run its own. As soon as this takes, for example, this statement takes, for example, 1 millisecond, okay? After 1 millisecond, it doesn't wait anymore. Now the control goes back to the caller here. So the print is done. Do you want to see what exactly happens here? Let's do it. First print is going to start. Okay. First print is done. Right? Let's do the same thing for you'll understand what exactly is happening. Oops. See? Now let's see what exactly happens. Let's print it now. You'll understand my point. See here, first print is going to start. Okay, it's going to start it. It called the print method, and the new thread is created and started, and then the control comes back to this guy, and it says that first print is done. It doesn't wait until that gets printed anymore because that's running in parallel. The main thread is different, and then this guy is different. And now second print, immediately second print started. Again, it went back here. It's happening here. Okay. So, and now it's the thread 1 is doing its job. It's running in parallel, and then see, comes back, and then second print is done. And then third print started. And again, no one is waiting. Of course, in between the other guys are coming into picture, and then they are getting executed. Okay. And then third print is done, and the fourth one is starting, and then fourth one is done. But everyone is doing their job. This is the thread 4, thread 1, thread 2. Everyone is doing this. See here. Thread 1 is printing, and immediately thread 3 came into picture, thread 4 came into picture, thread 4 all the way, and then fourth one is done, and again thread 1, thread 3. Everything is parallel. Everyone is doing its job. Everyone is doing its job. Okay. But who will run first? Now we have these 4 processes running in parallel, right? 1, 2, 3, 4. But if you look at it, the processor can actually do one thing at a time. The actual computer processor can do only one cycle at a time. So it gives you the feeling of this whole multi-threading, and everyone, no one is waiting. Second guy is not waiting, third guy is not waiting, fourth guy is not waiting for 1, 2, 3 done. Okay, but if you look at it, if you look at the nanosecond level, it's actually doing one thing at a time. So behind the scenes, what it does is JVM has a different thread called thread scheduler. So that knows who has to go next, who will get the CPU time. So for example, first thread. Okay, you do it, I'm giving it to you for 5 CPU cycles. CPU cycle is like tick, 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 for example, okay? So first thread got 5 CPU cycles, next third one got it, fourth one got it, second one got it. It just randomly gives it. In fact, you can prioritize that one too. You can say that, hey, second thread is it has more priority than third one. And fourth guy has more priority than first one. You can definitely schedule that one, but you cannot force the JVM thread scheduler though. You can only request and say that, hey, this is more priority, but JVM behind the scenes, several other things. It's a very complex algorithm. Honestly, I don't know about it, but it's very complex algorithm. Based on that one, it gives the appropriate time slice to each thread. But we don't care. We don't worry about all JVM is doing behind the scenes. What we care is our results. See this one? Beautiful. Everyone is parallel. See? Who finished last is number 2. We would think that probably the number 4th thread would finish last, but it's not up to us. It's not up to us. JVM decides that who gets the time slice based on several factors behind the scenes. Okay? So, but the end result is Java supports multi-threading, and you can span multiple threads and then have the things run in parallel without having to wait or without having to do it in serial fashion like how we used to do it in main thread. So main thread starts, and then the print method spawns a new thread, and then this is getting executed. Again, the same thing here. Again, the same thing here. Beautiful. Right? And now you can do the same thing with the other approach. We did the extends thread. Now we can do the implements runnable. This is another approach. You don't have to change anything. You don't have to change anything. That's it. Because there is an exact run method also in runnable interface. Same thing, same behavior. See this one? This time, the first one ended up finishing last. It all depends on the JVM cycle, how it gives the CPU cycle to you, to your thread. But, oh, see this one? This time, first one started, done, second one started, done, third one started, done, and fourth one started. This is not the behavior last time we got, because it's random. But you can give some priority, you can prioritize it, and you can change the behavior to an extent, but you cannot force it. Okay, so this is called multi-threading, and Java supports it. When you're doing an expensive operation, okay, and if you don't want, see, if this guy, see here, right? If you don't want this one to wait until this gets done, if this guy depends on this one, yeah, makes sense. But if this guy doesn't depend on depend on this one, then if you want them to run in parallel, go ahead and run it. span a new thread, assign the task, and then you give the control back to your caller and say that, yes, I'm done, sir. You know what I'm saying? So that's about it. This is about multi-threading. Yeah. Now let's go to questions quickly. Neetu is asking, can you please explain what is the difference between using extends and implements? We talked probably 5-6 times, Neetu. I should ask this question. That in fact, this is the whole reason why we spend that much time to explain it. Let me explain it again. If you use this extends a class thread, then you can only extend one class. Java does not support multiple inheritance, multiple concrete inheritance. So you can use this extends keyword only once in its life cycle. Once you do extends, you cannot say tomorrow comes back and say person. You can't do it. Okay, Java does not support that. That is why you should always go for implements. Implements runnable, or implements whatever the interface this one is. And you can implement as many interfaces as possible. For example, okay, you can have as many interfaces as possible. And now you can also have this extends. You know what I'm saying? So you can have both extends, implements in the case of this approach. So you can have, if you implement an interface, you can keep that valuable extends keyword for tomorrow, for extensibility for tomorrow. Okay, so that is why this is a popular interview question, Neetu and everyone else. Okay, so how do you span a new thread? Well, you can do it by extending a thread class or implementing the runnable. Okay, which one would you go for? Or they don't even go here. In general, they'll ask, hey, I have this, I can extend a class or implement an interface. Which one would you prefer? Well, I would prefer implementing an interface because I can keep that extends keyword for later. Because Java supports only one class extension. Make sense? Neetu? Very good. Any other questions? We can code to interface using implements. Yeah. In fact, Sirisha is saying we can code to interface using implements. That's not the most accurate answer, Sirisha, honestly. Code to interface is actually a concept, meaning code to interface or code to super type. It doesn't have to be an interface, but code to super type. So that's a concept. Rather than saying array list books equal to new array list, you should always say list books equal to new array list. That is actually code to interface or code to super type. Can we implement more than one thread at the same time? What do you mean? We did here, right? We spanned a new thread. I didn't understand the question, Geeta, here. Can we span?
No, I got it.
You got it?
Yeah, yeah. Actually, so runnable, serializable, those are the names already, or I mean, you created.
No. Sorry, I'm sorry. I confused you. I'm sure I must have confused other people too. So forget about the serializable. There is an interface called serializable.
Mm-hmm.
There is an interface called clonable. The reason why I typed this one is because I wanted to show that your class can implement more than one interface. That is why
Okay.
you go for implements rather than extends. Your class can implement more than one interface, and also you can still keep that extends keyword for tomorrow.
Okay.
That is why I just typed some interfaces. That's all. Okay.
So thread is the name you created, right? Not the
No,
keyword.
no. I'm sorry. Extends thread. Thread is inside a java.lang package. Java.lang package. Who gives you java.lang package? Java.util, all these things.
Okay.
JVM gives you this. I mean, Java gives you this one. It's part of JDK. As part of JDK, Java gives you a lot of fundamental classes that are used in your own classes. For example, thread, string. Where is that string class? String class is in java.lang package. Who gave you java.lang package? JDK, right?
Mm.
Does it make sense? No?
Okay.
Oh, Gita, looks like you're not fully
Yeah.
clear. No, I didn't understand. Tell me.
So thread is a already created class, right? So we are extending that one.
There is a class called java.lang.thread in. There is a inbuilt class within JDK called java.lang.thread. So this is a package, okay? This is a class. Java has given you. There is a class called string. All this while you didn't ask, how come, how did we get this one? This is a class given by Java.
Oh yeah, that's what I'm asking. Like thread is a class already. I mean, we need to modify that one according to our use, right?
No. Thread is a class that's given by JDK.
Oh yeah.
If you, no, let me finish. It's a class thread, okay? But there is a class called thread. Okay, now let's come to concept, the thread. You want to span your own new thread, Geeta. You want to do these 4 things in parallel, so you need a new thread. Thread here, thread here. I'm not talking about class thread here. I'm talking about the concept thread, Geeta.
Yeah, I got it. Yeah.
Okay, if you want to span a new thread, your class should extend a class called java.lang.thread.
Okay. Okay.
Does that make sense?
Yeah, yeah. No.
This is one way to do it. Or implements an interface called runnable. It is already there, and this runnable is also in java.lang package.
Yeah, yeah.
Make sense?
Yeah.
Sure?
Yeah, sure.
Okay. Anybody has any questions around that one? Can I create thread without name? Kranti, what's the question here actually? Kranti, Irfan, or Sunita? One of you asked more than one person. Okay, Kranti, you're there? Oh, can we give the user defined threads? These thread names are automatically given by the JVM, and these threads will be important in certain scenarios. Later on, I'll explain. Okay. These thread names are given by JVM, and these threads get, if you want to get the current thread name, you'll use this thread.current thread.get name. And then can you mess around the names? You can to a certain extent, but you can't do whole lot with the names actually. Later on, once we talk about log4j, I'll show you some examples of how you can little bit of, you can mess with the thread names. Okay, especially with the logging. Behind the scenes, it does that for you. You want to know what is the thread name of it, but you don't have a whole lot of creativity that goes on there. The reason is simple. You don't know all these threads are actually created dynamically. All these threads are created dynamically. So if you want to say thread name is Kranti, then what would be the next one? So you have to put the logic around that. And moreover, you're only requesting JVM to create that, to span a new thread. So who is doing the actual work for you here? So JVM is doing it. You're spanning a new thread and scheduling it, and everything is actually controlled by JVM. Okay, but we use that thread name to identify. It's going to be helpful to find out some how do I say this one? It's going to be helpful to find out which thread exactly failed in server. That's why I cannot answer fully right now, because I'll show you how this thread name can be printed to the console when we talk about the log4j. Okay, later on I'll talk about that logging thing. And the second one is that's going to be helpful actually to identify some of the errors when we look at the log files. So to answer simply at this point, without giving too many details, too much of information, and without confusing everyone, we don't have a hell lot of control over thread name. Okay, it's created by the JVM. It's actually controlled and then prioritized by JVM, and everything JVM controls it. Is there a limit for creating threads for a process? It's a good question, Sirisha. It's a really good question. The limit is your, it depends on your CPU power, how many threads it can handle. This thread is actually, this concept of thread goes into your CPU as well. Okay. So if your CPU supports, for example, if your CPU supports 400 threads, okay, so you can support up to 400 threads. In fact, you can fiddle around that in JVM itself. If you look at it, let me step back for a second. See, you have, you span, span a new thread like this here, right? Okay. One more thing that I mentioned just now is JVM has one more thread. This is a thread scheduler. Okay. The thread scheduler is also a separate thread that acts as a daemon thread, meaning the thread that's running in the background. So it acts as a daemon thread and it controls all these threads here. Okay. So it controls all these threads. So one process, I did not get there yet, but I'll talk about it in probably 5 minutes down the line or 10 minutes down the line, that all these threads are going to share the instance variables. Okay, I'll talk about that one. But each thread, when you create, when you span a new thread, you have to allocate some resources to it. All the local variables are going to be local to for each thread. And in your computer, if you have 2 gig memory, and then if you allocated 1 gig to your to your JVM. You do that as part of one of your JDK properties, JVM properties, minus XMS, minus XMX, and so on and so forth. So if you allocate 1 gig, so if you span 1,000 threads like this, and each thread, keep in mind, each thread needs some resources, because each thread is going to have its own separate copy of these local variables, but they're all going to share the instance variables. I'll get there in a few minutes. So there is definitely limitation. So infinity is not the answer. Absolutely, there is a definite limitation. It depends on how much space, how much memory has been allocated for your JVM heap, and depends on your processor. So you will run into out of memory issues if you span more than threads. But again, is there a certain number? If you're looking for 100, 200, something like magic numbers, there's no magic number. There's no magic number. So later on, I'll talk about how this multi-threading concept is used by these web servers. So most of the web servers, since we don't know at this point, the other day I talked about this one. You open up a browser and go to Amazon.com. As I told you, the request that you made from the browser will be taken by Amazon web servers. If that's written in Java, and if they're using some Java-based servers, they must be using one of these. And after HTTP servers, the actual server that takes it would be your Tomcat, JBoss, or WebSphere, WebLogic, one of these Java-based app servers. There, they provide an option to provide how many threads each user. So all of us here, Chaitra is trying to shop here, and Sirisha is doing something here, Venkat is doing something here, Irfan is doing something here. All of us, we're all trying to go to Amazon. So there, in the configuration of those web servers, there you can specify that, hey, I don't want to span more than 400. I don't want to span more than 500 threads. You can definitely do that. But you are actually controlling at the Java level. So you are putting the artificial boundary to that, to the number of threads. So the Tomcat or WebLogic, WebSphere, they are doing it. But the Java itself, if you don't do it, there is no definite number where it stops. No, it all depends on your resources. Okay. So that answers. Now Rakesh has a question. Yeah, Rakesh, go ahead. Hello. Rakesh, do you have, if there is another, yeah, Rakesh.
Can you hear me?
Yeah, I can.
Yeah, what if there is another object created on the same class, and it wants to call the run method and print from 10,000 to 20,000?
Let me repeat the question, okay? Let me make sure I understand your question. So what happens? It's a beautiful question. So what happens, or how can I have one more thread after this guy? This is printing from 0 to 10,000 here, right?
Yeah.
Okay. So how can I have one more thread? How can I have one more thread to start printing from 10,000 to 20,000 and have one more?
The entire same process which we did for 1 to 10,000, like 4 threads.
Yep. Yeah.
Another same process like 10,000 to 20,000, the 4 threads.
Okay. You have to wait for a few minutes, okay, for that answer. I have to explain the concept there. Then I
was thinking like again you would override the run method with different arguments.
No. Actually, if you look at it, okay. To answer your question, that logic has to be controlled outside of this one. See here, That's why give me a couple of minutes. Let me
Sure.
explain something and then I'll get to it. Okay.
Yeah.
Okay. A lot of good questions. Very very good questions. Now I want to say something here. So we talked about all these multiple threads, right? We have a one process is spanning multiple threads. Now, again, as I said, thread is not a process. It's very lightweight, and it's actually a path of execution within the process. So you can have multiple parallel paths of execution, which gives you the feeling that not only the feeling, it actually they are running in parallel. Okay, why do I say gives you the feeling? Why did I use that? I'll get to that later. I'll defer that discussion. The important point that I need to talk about here is, in fact, I'm going to relate some of the questions asked here. One important point here is all these threads are spun from a single process. Okay. So all these threads share some resources that they acquired from the process. But each thread will have its own resources too. So what is going to be shared by all these threads and what is not going to be shared? What would be the copy? Can thread 1 knows about thread 2? So what exactly happens behind the scenes? Well, these are the rules. The rule is, if you look at this one, you have the same line of code here. If you write within this code, if you write a lot of logic here, like 100 lines of code here, okay, you have a single instance method here. Keep in mind, this public void run is a single instance method. It's not a static method. It's a instance level method, right? All the instance variables are going to be shared by multiple threads. This is the rule. Instance variables will be shared by multiple threads. So what are the instance variables? You know instance variables, fields, and everything. If I have okay, so these two are the instance variables. All the instance variables are going to be shared because these are actually 4 different threads that are running in parallel right now. All the 4 threads will have access to the instance variables, and these instance variables are going to be shared by every single thread. That's the rule. And the important point here is this method is getting run by multiple times, right? This is the crucial method that we talked about. How many threads created here? 4 threads are created, and all the 4 threads are trying to execute the same lines of code, these lines of code, the highlighted lines of code. There's 5 lines of code. And all the 5 lines of code will have access to the same instance variable. So instance variables are going to be shared across all the threads. What does it mean? Well, what it means is, okay, the first thread comes into picture. It's going to the for loop here, and then it changed the printer name. Okay, it changed the printer name to something, and now immediately the next thread, while changing the printer, the second one came and read the printer name. While doing that, the third one came and read the printer name. So fourth one changed it. So you don't get the parallel behavior if you are not careful, because some resources are being shared by all these 4 threads here. Some resources are going to be shared. These are instance variables. These instance variables are going to be shared by every single thread. Earlier we talked about something called static variables. Static variables are going to be shared by every single instance. But as I told you several times, every single instance will have its own copy inside the heap. This is an instance, this is an instance, this is an instance. But the static variables are stored somewhere here, and everybody will have access to that guy. That's a static variable. But what I'm saying is, inside the instance, now every instance has a separate copy. Inside this one, you will have a thread 1, thread 2, thread 3, thread 4. All these threads will have access to the same instance variables. So if your code is modifying the instance variables in a multi-threaded environment, you have to be very careful, because this is the same line of code everyone is executing in its own fashion. Well, this whole line of code, okay, my thread 1 has this whole 5 lines of code. Thread 2 has its own 5 lines of code, but unfortunately everyone has access to this guy. I have my own execution environment, and it has its own execution environment. This guy has its own execution environment, and the fourth one also has its own execution environment. But unfortunately, I can read this guy, and then this guy can write it. This guy can read it. This guy can write it, because we're talking about the fact that the instance variables can be shared. Okay, so you have to be careful when you use the instance variables in a multi-threaded environment, especially when instance variables are going to be writable. If they are just used as constants, just as read only, not a problem. If I'm just reading them, not a problem, right? There are no thread issues because everyone is reading only. But the problem comes into picture when one guy is trying to read while the other guy is writing it. That's where the problem is. There is a name for that called thread safety. So to put this in a different words, instance variables are not thread safe. Instance variables are not thread safe. You need to understand this one. Instance variables are not thread safe. Because instance variables are going to be shared by all the threads, by multiple threads. So it can potentially happen that one thread will be writing, the other guy will be reading. So that's why if instance variables read write in a multi-threaded environment, you'll have to be a little careful. Now let's get down to something called local variables. So we talked about static variables. Static variables are even big scope, right? Everyone will read, everyone can read, every instance can read. But now let's talk about, so here I'm kind of answering both the Rakesh and Srisha's answer. See here. Now inside the public void run string first name equal to something. Okay. These two variables are called method level variables. They're also called local variables because these are defined inside the method. The scope of these variables is only within the method. If I try to access my first name in a different method, for example, public static void main, I'm just saying, this guy is not visible here. Because the scope of that variable is only method. So these are called method level or local variables. So these local variables are not going to be shared by all threads. Every single thread will have its own copy of the local variables. So local variables, to put it in a different words, local variables are thread safe. So local variables are thread safe. Why? Why are they thread safe? Because every thread will have its own copy of the local variables. Like every instance has its own copy of the instance variables, unlike the static. Every thread will have its own copy of the local variables. That's why local variables are thread safe, instance variables are not thread safe. So when multiple threads enter into the same execution code and when they're writing, when they're changing the value of instance variables, be prepared to handle the scenarios where multiple threads enter into that block of code and then they both are fiddling it. One is writing, one is the other one is reading. So you will expect, you'll get the unexpected behavior in that scenarios. That is why you have to code in such a way that your code handles all those unwanted scenarios. Because by nature instance variables are not thread safe, but local variables are all thread safe. Here you write whatever, you define 100 variables, absolutely not a big deal. The thread 1 has its own variables. Thread 2 in this scenario, right? We have how many? 1, 2, 3, 4. We spanned a new 4 threads here, right? In this example. Thread 1 will have these separately. Thread 2 will have its own copy. Thread 4 will have its own copy. The same thing with these variables too. See, for int I equal to 0. Thread 2 has no clue about the current value of this I because thread 1 will not share that information. That is why you can't rely on these I's to print 1 to 10,000. Thread 1 does it. Thread 2, 10,000, 1 to 20,000. Thread 2 has no clue about what the I value of the thread 1 is because it's not visible because of the local variables. Local variables are not shared by multiple threads. How about this one? Absolutely, these are going to be shared. Okay. So instance variables are not thread safe and local variables are thread safe because everyone will have its own copy. Okay, but we talked about a lot about the instance variables and how do we avoid this one? We we typically run into this situation where I have to write into these instance variables. Well, we talked about static variables. They have their own place, but instance variables are very important, right? We talked about everything object, 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 right? So, but you're saying now, not thread safe while writing, you'll run into this situation where one thread is reading, the other thread is writing, right? So, what you can do is, if you have some sensible code, if you have some few lines of code, or if you have a method which manipulates the instance variables, and if you think one is manipulating, the other one is reading, and if you think there could be a potential clash when multiple threads enter into that block of code, then handle that scenario. Java is giving you a way to handle that scenario as well. That is called synchronization. So you can synchronize all these threads. So for that block of code, for that important piece of code, or for that important method, what you can do is you can have only one thread enter into that block of code only once. So the second one cannot go into that method or into that crucial block of code until the first one comes out. So you're doing serial fashion here, but you are running everything else in parallel. But the sensitive part of it, which could give you some issues with the threading when multiple threads enter into the same block of code. So that is called synchronization. You can use a special Java keyword called synchronized. If you use that synchronized, then you will not run into these issues. What happens behind the scenes is it will not let the second thread enter into that block of code until the first one comes out. So there is a gatekeeper. There's a gatekeeper. It says that, hey, you guys are in queue, okay? There are 4 threads that are waiting for the resources here. All these 4 threads are waiting to write into, or they're trying to execute this block of code here, okay? Then they say that, but this is a very sensitive part because they're all you writing, reading, and manipulating these instance variables, and we could potentially run into this conflict with multiple threads. So there will be a gatekeeper saying that, hey, okay, first one, you go in. I'll give you lock. It's called lock. I'll give you lock. Okay, as soon as you come out and the lock is open, and now I'll let the second one go. So the second one, third one, fourth one are in queue. Once the second one goes in, now the third and fourth, they'll be waiting until the second one comes out. It's doing in serial fashion. Well, you said multi-threading and all that stuff. Yes, you're doing everything in parallel, but whatever the sensitive, because we talked about the advantages of it, now I'm saying you can potentially run into this situation where it's going to hurt you. So let's run them in serial using the synchronized keyword. So if you use synchronized, you can use it at the method level. So you can use the synchronized keyword at the method level. This is called synchronized method. What exactly is meant by that? Well, synchronized methods get executed in serial fashion. Multiple threads will not enter into that method. One thread will be waiting. All the other threads will be waiting while the first thread finishes up. That's what a synchronized keyword. That's what it does. There is a disadvantage too. So synchronized is cool to avoid the multi-threading issues. It's good. Okay, but you have to be extremely careful before using synchronized. Synchronized has its advantages so that you don't run into this multi-threading issues while multiple threads are using the same instance variables, because instance variables are by nature are not thread safe. But you have to be careful with synchronized keyword too. It has advantages, but it hurts you because you are not taking advantage of that multi-threading environment. Only one guy is going into that block of code, and while other guys are waiting. So your application will not be scalable. Meaning, it can do if 10 threads are waiting, okay, or 100 guys are waiting. You can't make your application scale up to 1,000 people, because these other 999 people, they'll be waiting forever, right? By the time the 1,000th thread gets the chance, it will be too late. So your application will not be scalable. Probably you can do 5 people, 10 people, yeah, 5 parallel guys you can let them enter. 10, yes, you can do it. Probably 20, yeah, maybe. But it's not scalable more than that, because it's doing in serial fashion. Performance, absolutely performance bottleneck. It does one at a time. You don't want to do it, and you're not leveraging everything. That is why exercise caution before using the synchronized keyword. It has its place, it has its advantages, absolutely. But don't use the synchronized keyword for the whole method. What happens if my method has 1,000 lines of code? Any method should not have more than 50 lines. That's our general coding principle, this one. I'm just telling you, even 50 lines of code. Even 50 lines of code is too much. Because if it takes a couple of seconds, there might be a lot of threads waiting to get the lock to go into that block of code. And you're doing one at a time in a serial fashion. So don't use the synchronized keyword for the whole method. You can do it at the block level. There's something called synchronized block. You can use the synchronized block. If you think these 2 lines are crucial, okay, then use the synchronized block. So this is where you are writing, okay? This is where you are actually fiddling with the instance variables, okay? So you can actually create a synchronized block around those lines of code, and then you don't have to use the synchronized for the whole method. So use the synchronized block of code, like how we have the static blocks. That's a block of code, right? That's a static block of code. Similarly, we have the synchronized block. In fact, in the case of synchronized, you can make only one object serializable, one object to run in serial too. So what you can say is, hey, I have these 10 instance variables. 9 of them are okay, but one of them is extremely crucial. No way multiple threads can read and write this guy, because this is very extremely crucial guy. Everyone else is like, it's okay, they'll have their own copy or read, write, not a big deal. But this guy is crucial. So you can get lock on that particular resource, and say that, hey, I want lock on this guy. Only one guy can enter into that. You can say that. So limit the usage of the synchronized block to as minimal lines of code as possible, as less as possible. Do not use the synchronized for the whole method. If possible, avoid it. If it's a small method, yeah, no big deal. Okay. But if it's a big method, then go for synchronized blocks. And this is actually about the synchronization and synchronized keyword. Now I want to tell you one simple thing here. We talked about, this is very important in interview perspective, even after you enter the organization. We talked about string class. String is an immutable object. And now we talked about string buffer as well. String buffer is a mutable object. You can change the state. You can keep adding, appending. We did this already in toString method. We have I showed you how to use string buffer. In JDK 1.5, they introduced one more class called string builder. Okay, they introduced this new class called string builder in JDK 1.5. There is a difference between string buffer and string builder. Both of them are immutable. This is immutable. You can't change the string object, never. But string buffer, you can do it. String builder, you can do it. But there is a difference between these two. When they designed the string buffer, they designed the string buffer as a synchronized. This string buffer is thread safe. They designed string buffer as a thread safe object. So this is thread safe. Okay, that sounds like a positive thing. Well, not necessarily. The reason is, let's go to that toString objects. I believe this is where we wrote our toString method. See here, string buffer person equal to new string buffer. Take a look at that line of code again. String buffer is designed as a thread safe object. Okay, behind the scenes it uses synchronized. So string buffer is synchronized. In another way, string buffer is synchronized. String buffer, if you look at it, is synchronized. See this public synchronized string buffer append. Every single method is synchronized here. So this is a synchronized string buffer. I just opened the JDK's code. Okay, see this one, JDK code. You can read this like our code. You can learn a lot of things from JDK code. Okay, see this, every single method is synchronized. Every single method is synchronized here. It supports multiple threads. When multiple threads enter into this block of code, nothing happens. No side effects. Absolutely works great. But my immediate point here is, do you need synchronized here? Tell me. Do you need synchronized in this line of code? What is this person variable? What variable is this? Is this an instance variable or local variable or static variable? What is this? This is a local variable or method level variable. This is defined within the method. This is a local variable. And what does the rule say? Local variables are inherently thread safe. This is already thread safe because of the nature of the variable. Then why would you need string buffer in that case? Why would you need the synchronization? And synchronization hurts, and synchronization takes away the performance. It's a performance bottleneck. Of course, it helps with the multiple threads, but it doesn't give you the performance. So if you're constructing any string buffer within the method as a local variable, go for string builder. String builder is not thread safe. String builder is not thread safe, but we don't need thread safety in the case of local variables. It gives you a lot of performance because multiple threads, when multiple threads are entering, well, you have its own copy because person, anyway, this guy is inherently thread safe because this thread will have its own copy of it, and the thread 2 has its own copy, thread 3 has its own copy, every single thread has its own copy of it. Then I don't need it. When you append it, you don't have to worry about this append. There is no synchronized here if you look at it. There is no synchronized. So this is not thread safe. That's okay. I don't need thread safety here. So 95% of the cases you use string builder because you'll be constructing all these string builders within the methods, and within the methods these local variables are always thread safe. You don't need thread safety, so go for string builder. And what is the difference between string buffer and string builder is an absolutely asked interview question. String is immutable. String buffer and string builder, both of them are mutable objects, but string buffer is thread safe. It's synchronized, but most of the times we don't need synchronization, especially in the case of local variables. Local variables are inherently thread safe, but string builder is not thread safe. That's okay. I get more performance because every thread has its own copy. Inherently, my local variables are thread safe anyway. I don't need this extra safetiness through the string buffer. I don't want to hurt the performance. So I'll get more performance. So string builder is faster than string buffer, to put it simply. So go for string builder. But it's not but understand the context also. If you want to put the string builder as your instance variable, no. Instance variables are not thread safe. They are used string buffer. In the case of local variables, absolutely go for string builder. You get more performance. It will be faster. And what's the synchronized keyword? What's the multi-threading? So it's important interview questions. Okay. So use string builder, use string builder, use string builder. Ask every single time. If you have to use string buffer, ask, why am I using string buffer anyway? Do I need thread safety here? Am I talking about the local variables, or am I talking about the dangerous instance variables? Okay. That's about the thread safety, synchronization, and all that stuff. Next one is there are a lot of similar questions on thread safety and synchronization generally asked in interviews. We talked about Java collections framework, right? In the Java collections framework, we talked about array list. We talked about array list. We did a lot of examples and all that stuff. Before JDK 1.5, now this is actually Java collections framework was introduced. I believe it's 1.4. Yeah, it's long back. Okay. I think back in 1.2 or 1.3, we still have this in JDK. There is a class called vector. It does a very similar thing. It's exact same thing. Another way. Okay. It can do the same thing. But the difference is array list is not thread safe. Not thread safe. Vector is thread safe. Okay. Same whatever the explanation that I just gave you for string builder and string buffer. This is string buffer, right? This is thread safe. And string builder is not thread safe. Well, if it is not thread safe, what do you get? What do you get if it's not thread safe? You get performance, because behind the scenes it's not synchronized, and synchronized hurts the performance. It's a bottleneck, performance bottleneck. Synchronized keyword is always performance bottleneck. But of course, you have to use it. Exercise caution while using it and limit that to only certain lines of code. So this is one of the interview questions, they ask, what's the difference between array list and vector, string builder and string buffer? And one more thing is, we have seen hash map. And there is another class called hash table. It's kind of a same approach. Hash table is thread safe. Behind the scenes, user synchronized. Hash map is not thread safe. Okay? Array list, vector, hash map, hash table, string buffer, string builder. These are the general entry questions they ask. These three are not thread safe. Sorry, thread safe. These are three are not thread safe. Of course, most of the times we use array list. Most of the times we use builder. Most of the times we use hash map because we don't need thread safety in the case of local variables. But they have their own. They have place, definitely. You know, if you're dealing with the instance variables. Instance variables are kind of a dangerous zone. So instance variables are not thread safe because every thread will have visibility to those instance variables. So exercise caution and use carefully the synchronized keyword. Okay. Few important things. That's it. You don't need more than that for multi-threading. If you care about it, okay, now I'll tell you some practical things. When would you use it in your, once you enter the application, any company, where would you use this multi-threading? When would you span a new thread? Well, one scenario is a lot of companies have two kinds of applications. One is the web applications like Amazon.com, Yahoo.com, Google.com, like web applications. And they also have the batch applications. We also call them scheduled job or batch job. Like banks, okay? They do all the intraday calculations, right? So they do 9 to 5 and they store it in a temporary fast-paced database. And then after 5 o'clock, all the intraday stuff, they just put it in their big database, mainframe or whatsoever. Okay? So there are like a batch job or scheduled job. They run at certain intervals. So these batch jobs are nothing but simple main classes. They'll have a public static void main, and simply the way you run is Java, whatever the batch job it is, right? Cleanup job or whatever, some batch job. And generally these batch jobs run for minutes, hours also. It might take 2 hours to run it because we're talking about millions of records, right? So it takes a lot of time. And if you look at this mass emailing, right? Like we get monthly statement. Every month we get the monthly statement from bank. So all the monthly statement generation, it doesn't have to be a web application where somebody has to go and click. It doesn't have to be. And it runs once a month, right? It can be a simple batch job, a simple public static void main, having public static void main, and then that runs for hours, and then it generates a PDFs and sends an email to every single customer. If I have 1 million customer, yeah, it takes, if not 2 hours, it takes 8 hours. When you do it, then calling program, whoever is calling it, whoever is kicking off this whole public static void main, right? So if there are few things that I can do, one is printing the statements, like generating the PDFs. This is what I mean. Generating the PDFs, generating the statement here. One guy is generating the PDF. You can have sending an email saying that their statement is available. Ideally, you want to wait until the statement gets generated, but if you don't want to wait, if it can be done parallel, well, you can have 3 different batch jobs, or in some scenario, even if you have 3 different batch jobs here, generating the PDFs takes a couple of hours. The caller, whoever has called it, it doesn't have to wait until 2 hours. You just span a new thread and allocate that one, and the main thread can come back. There is one more thread that's running in parallel. So if you want multiple things to run in parallel, and if you have the computing power, if you have the proper hardware, then span different threads and then allocate the work assignment, and they'll be running in parallel. Nobody is waiting for anyone. This doesn't have to wait until this gets done. Kind of one of the scenarios, but I'll tell you now, honestly, we don't see this code spanning a new thread, okay? In my whole career, pretty much how many times did I span my own threads and then wrote this kind of code? Probably 4 or 5 times. I'm not exaggerating. Yeah. We don't do this on a daily basis because most of the times we'll be working on these web applications. Even here, it's a simple thing. This is not our bread and butter. We don't deal with this spanning a thread and then allocating it. So we don't do it on a day-to-day basis. I can guarantee that. Okay. In interviews, what they ask is, how do we create the thread, extends thread, and implements runnable, and then what's the synchronized keyword, advantages, disadvantages, difference between all this string builder, string buffer, and all that stuff. Okay. But now I'll tell you more. If you work for Spring Source itself, we are using the Spring Source tool suite, right? So if you work for any of the companies who build these tools, absolutely, they use multi-threading. If you work for the Tomcat is a web server, okay? JBoss is a web server. It's application server, okay? Then let's not get into that. Both of them are called application servers. They take the request from a web browser and then they respond to it. Like Amazon.com. Amazon.com may be running in a JBoss or WebSphere, WebLogic. There are multiple vendors, okay? If you work for one of these companies, if you're building this kind of server, if you're building this kind of tool, absolutely, this is where you have to leverage this multi-threading environment. Because here, what you want to do here is, I'll tell you what happens behind the scenes. Browser makes a call to Amazon.com, okay? Here, there is a JBoss here. Now let me take some people randomly here, Davluri, Sirisha, whoever I'm seeing here, Gayatri, Geeta, Chaitra, okay? All these people are entering here. Okay, they're all going to a particular Java program there behind the scenes called shopping cart or login. Okay, behind the scenes these Java programs are called servlet. So login servlet or shopping cart servlet. So Chaitra, she's doing some shopping, and then the shopping cart servlet is busy, and she's using it, and now this guy is waiting here. If you want to do this serial fashion in JBoss, wait, I don't have a shopping cart. I only have one cart in my whole Amazon. Sorry, I cannot give you one more. She has to finish it and then give it to you. Is that scalable? How many can shop in Amazon in that scenario, right? So that's not possible. You can't have just one simple process. But how about creating multiple process itself? multiple login servlets and that kind of stuff. But that's very expensive stuff. So what happens behind the scenes, all these web servers, what they do is, when they get the request behind the scenes, they span a new thread. What all they do is, new thread of whatever that object is, the login servlet, and then say start, and then it runs the run method of that guy, and then there will be logic, and now Chaitra is being taken care. Now Dowluri can come in and he says, again the same thing. JBoss doesn't wait for her to finish. No, I can create a new thread. You create new thread. And then, who is this? Yes, someone. So, came in, this guy came in, and then same thing. Oh, Sirisha, Gayatri. So new thread, new thread, new thread, new thread, new thread. As soon as you get it, you will have your own separate thread. In fact, this is one of the reasons why Java has been dominating for years in this area. Server-side web, what do you call it? Yeah, server-side web. The client-side web and server-side web. So server-side web. Earlier, they used to use CGI. So for every single guy, they used to create a brand new process, which is very expensive, and you can only have so many processes in your computer, right? But here you're talking about one processing, splitting that into hundreds of threads, minute, tiny little ones. That's the beauty of it. So they use this multi-threading, and this is how they span. This is how they become scalable. And in fact, I did not talk about this because it's not required. In JDK 7, they have improved all these multi-threading concepts. Until JDK 6, though I told you, that is why I was telling you earlier that you'll get the feeling that all the 4 threads are running. But unfortunately, this processor can take one execution at a time. Though they're all running parallelly, but if you take one particular nanosecond, this CPU is doing only one job at a time. Though you have multiple cores in CPU. So you're not taking advantage of it. Actually, in JDK 7, they introduced more concepts to leverage this multi-core concepts, because multi-core, everyone is multi-core now, right? Every computer. Come on, your iPhone has at least two cores. It's a dual core or quad core? I think it's dual. At least it has 2 cores. My computer has 6 cores in it. So it's right. So if you want to take advantage of that, they introduced more concepts, but as I told you, I don't want to waste the time. Rather, we talk about something else. You're not going to use it, and they're not going to be asked in the interview. So, and this is not for academics. So, okay. We talked about whatever needed, but it's a big topic. Actually, there is a book on multithreading. There's a big book on multithreading. I think Joshua Block wrote a very good book, Concurrency, Java Concurrency, I believe. Joshua Block wrote an excellent book. But we don't need all that stuff. Okay, just synchronized, and this is good enough. You'll not be using it. This is where we'll be, and behind the scenes, the servers will be using it, and you can configure the server to answer one of the questions. You can configure the server. You can say that, hey, how many threads can I span? 400, 500, 600. So as a user of JBoss, you'll specify in some configuration file, and JBoss behind the scenes will take care of it. But is the JVM restriction? No, it's our application restriction. It's a smart restriction, so that we don't run out of memory. because JVM by default supports as much as you do. And keep in mind, each single thread is getting a separate copy of instance variables. That is why it's not infinite. Keep in mind. Any other questions? And in fact, if you go little down in multi-threading, you can have these threads sleep for some time. You can wake them up. And you can say that, hey, notify me, I'm sleeping, notify me when something happens. So all these 10 threads are running, and one guy, he says, hey, I'm sleeping. You can sleep for a certain number of milliseconds or certain number of seconds. Or you can sleep until something happens. I will sleep until something happens here. So when that something happens, JVM will notify me saying that, hey, come on, wake up, wake up. So you can do all that stuff. In fact, using AWT and multi-threading, they used to do some fancy graphics. Oh yeah, because there are multiple processes. One guy will be drawing, the other guy will be spinning, the other guy will be, all of these things are happening in parallel, right? So you can write some very cool stuff. But is it practical? Does it buy you anything in your, once you enter the practical life? No. Okay. Rather we spend more time on exception handling. That's more day-to-day stuff for us than multi-threading. But it's important too. Keep in mind, synchronized, generally it's a popular interview question, and then all these things. Any questions? I want to talk about exception handling, but looks like we can't now because that takes another hour and a half. Any questions? I'll take questions though. Okay, so Sunita's question is, I just started the recording. That's why I'm explaining your question, Sunita. So to run this thread, or you explain again, you ask again, Sunita. You ask again. I'll have you say that in my recording.
To execute that.
Mm-hmm.
To execute that run method, do we need start method?
Okay, very good. See this, Sunita. I commented out, you don't need it. This is, you are running it. Okay. So someone called the print method and I call the run method. Like any other method, right? Like any other method. And I'm printing 1 to 10,000, 0 to 10,000, 0 to 10,000, I'm printing. So observe the difference. Here, things are happening one after the other, like we expect, Sunita. There is only one thread, that is main thread here. So main thread printed this guy, this line, and then called this print method, and print went here, and then this run method called. So it is printing all 10,000 numbers, and then going into this statement, then it will write this statement, and then it will call all the 10,000 numbers will be printed, and it will go here, and then it will go here, all the 10,000 numbers will be printed, and it will go here, all the 10,000 numbers. It's one after the other, one after the other, one after the other. This is what we have been doing it. Here there are no multiple threads, Sunita. There is only one thread, that is main thread. This is what we have been dealing with. This is boring way of doing. This is what we have been doing it. I was saying, observe the output here. After 10,000 are printed, first printing is done. Second one is going to start. And then after 10,000. So this is single thread, only one thread, one after the other, one after the other, one after the other, one after the. This is what we have been doing. But this is not what we want to do it. This line of code does the magic. Just every single time, the moment you call me, I'm spanning a new thread and starting it. What exactly happens when I start the new thread? Then my run method will be called. But run method will be called on its own thread. So after this line of code, I'll give it back to my controller comes back here. So this guy thinks that, oh, print is done. As far as I'm concerned, I'm done. Something is running in the background, Sunita. As far as this main method is concerned, I'm done. As soon as the new thread starts and then delegates the job to that guy, controller comes back and say, hey, I'm done. But is it really done? No. The guy is actually doing behind the scenes. You know what I'm saying? So even if you take just this one, see here, see this, Sunita? Simple example. First sprint is going to start, and then within a millisecond you said first sprint is done. But is it done printing? No. A new thread is spawned, and then that has been, this task has been delegated to that new thread guy, and he's doing behind the scenes. But as far as my main one is done, I'm done. This main one is done. This main thread is finished. Everything is done. But there was another thread that was spawned, and that guy is doing behind the scenes. But as far as I'm concerned, what did I do, Sunita, here? I just kicked off a new guy, and then I asked him to do it, and I said, hey, I'm done. If I have to send an email to someone, email sender dot send success notification or something like that. Okay, I'm sending an email, but my customer is getting an email that everything is taken care. But is it really taken care? No, it's really happening. But am I waiting until that gets finished to notify him? No. I just spanned another guy, and I gave him the job, and I'm notifying my customer that, hey, boss, your work is taken care. Don't worry. If there is something, then I'm going to take care of it. But my customer is not waiting. Does it make sense? I mean, try to understand the difference. It's a huge difference between these two. Just simply calling the run method versus spanning a new thread and starting it. Makes sense? Tell me honestly, everyone. I mean, did you get the point completely into your bloodstream? It's important. Please understand that. Okay. If it's a little confusing, go home, watch it again, and then come back tomorrow with questions. We'll fix it. Yeah. So Sunita, did you get that completely?
Yes, Venkat.
Yeah.
And I have one more doubt
Sure.
also.
Absolutely.
The beginning I already asked. So for threads we don't need reference variables, right? We don't need to create reference.
What do you mean? Oh, here?
Yes.
If you want to do it, do it. Yeah. What's the big deal, right? Thread Sunita equal to new thread of this guy. And what are you doing? Oops. Right?
Mm-hmm.
It's not only for threads, Sunita. It's a simple concept. That's all. See, for what do I call this? Inline. Rather than doing it in 2 lines, I'm not using it anyway beyond this method, right? If I have 10 more steps to do it, other than the starting, if I have to do it, okay, let me give some meaningful name, okay? I'll give, it's a new thread, okay? Thread, new thread equal to new thread of this, and then new thread dot start, okay? if I'm doing something else, if I'm doing something else, if I'm doing more than one thing, makes sense. I'm setting the priority, okay? If I'm doing more than one thing, makes sense, Sunita, right? Otherwise, if I'm just starting it, I can do this without creating, without assigning to a variable also, right? I'll just do this one. And I'm just saving one line. That's all. It's nothing to do with, it's nothing to do with threads, nothing. Anyone, you can do it. I hope that, that helps. Not only for Sunita, everyone else. I'm just saying, generally people do it, Sunita. See here, address, right? Address equal new address. If you want to do several things on address, yeah, you need this one. But see here, you're doing a lot of things here. If you don't want to do it, all you do is new person dot toString or something. I just saved a line of code there. That's all. Wonderful. But nothing to do with threads though. Nothing to do with threads. You can call any guy like that. Okay. New objects or whatever the class, new person, meaning you instantiated. Obviously, by this you got already instantiation and you got the instance already, right? And you say .get address, and you got the address by now, right? Some people go, okay, inside the address I want the street, get street. This can be written in 3 lines or in 1 line. Person equal to new person, and I'll say person dot get address, I'll get the address, and then I'll say address dot get street, or I can simply just do it like this. It's pure preference, whatever you like. Inlining is okay. Inlining, I like it. That's it. So we'll meet at the same time tomorrow and talk about exception handling. I was hoping to do it today, but a lot of good conversation, but I'm very happy though. You all got the concept. So we'll see you tomorrow. Okay.